So chapter 5, section 6 is direct variation. We're looking at basically how are two variables related to each other. Is x directly related to y? And want to say a couple bullet points for what's going to be true about things that are this direct variation. First thing is if you have some points that fit this, it's going to be a straight line. When you connect the points, it'll be a straight line through the origin. So straight line through 0, 0. It's going to fit within an equation, so the equation, I'm just going to do EQN to abbreviate equation, is going to be y equals kx. K they have K stand for constant. They don't use C for constant because C is the speed of light. It stands for, I think, celeritas, which is like Latin for swift. Okay, so K is just going to be constant. And K is the slope, where K equals the slope. We should get a little bit more about that later. And I'm going to say K is called the constant of variation. Constant of variation. But that constant of variation we're going to go on and find is the slope. So those three things are going to be true for direct variation. Okay on that? Then I probably should have put a Roman numeral 1 before that. Instead, I'll just, I guess, start with my Roman numerals here and say Roman numeral 1 then is going to be, is this equation direct variation? So is the equation direct variation? And this is going to be one of the type of questions you're going to get. So example 1. We said the equation up above has to be this y equals k times x. So if we can get an equation into that form, it's going to be direct variation. So that's really what we're trying to say is the equation that form? Now the problem is sometimes equations could be in that form but look very different. So if I start out with an equation in standard form for a line, so if I have negative 6x plus 2y equals 0, looking at that initially, it's like, no, that is not a y equals some number times x. Agreed? But the question is, if we would take this and solve it for y, does it work out being a nice y equals something times x? Well, what's the first step in getting y by itself? You could. I'd do one step first. Okay. If you divide by 2, I wouldn't write this if I were you. If you divide by 2, you need to divide everything by 2, which would give you a minus 3x plus y equals 0. I found most people, when they start out dividing by 2, they don't divide this thing here, and they end up with a 6x there, a minus 6x. So that's why I'm encouraging you not to divide by 2 first. If you know what you're doing, if you know how to divide everything by 2, there's no reason not to. But I would start by saying, let's add 6x to both sides. Merely because I think you're more likely to get it right if I do it this way. So I have 2y equals 0 plus 6x, so 2y equals 6x. Then last step in getting y by itself, now if we divide by 2, I move this down a little bit, so I have my y equals 3x. So that original equation, is it direct variation? Yes. It doesn't look like it, but you could say yes. The key to that then, solve for y. For y, and check if it fits y equals kx. And k, I'm just going to say that has to be a number. So does it fit y equals some number times x? That's really the key. Sometimes you maybe can look at that in your head. Any questions on that section? So if instead this had been like a 3x plus 2, then it wouldn't work. The real key here is that this number here started out as a 0. If we had a 2 there, then it wouldn't have worked. The second thing I want to cover here is going to be, instead of if you have an equation, would be, are the points direct variation? So are the points direct variation? And there's a couple ways that you could do that. So I'm going to have a Roman numeral, well, a letter A and a letter B. And first thing would be check by writing an equation. And this is what you guys were doing in the earlier. So check by writing an equation. So I'm going to take my example and have my example be a data table. And my x values, I'm going to go with 1, 2, 3, 5. My y values 4, 7, 10, and 16. So the key to these are, you're saying, well, when x goes up by 1, what's y going up by? That's how I start. So we have x going up by 1 from here to here and here to here. And each time x goes up by 1, y is going up by 3. So we have plus 3, plus 3. So we know the equation then is going to be y equals 3x, at least for part of it. Because now when x goes up by 1, y is going to go up by 3 naturally every time. Good? But does that fit? So if I take my first point there, my 1, 4, I put a 1 in for x, 3 times 1, y is supposed to be 4. Okay, so plus 1 I heard. So I need to add 1 to it. So in other words, my equation then has to be 3x plus 1 to get that first point to work. And it's probably smart to say, well, if it works for there, does that work for all the points? Well, if I take now my second point, so if I look at, well, when x is 2, 3 times 2, 6, plus 1 gives me a 7. So sure enough, that it fits the second point as well. Good? Okay, so now y equals 3x plus 1. Direct variation, not direct variation. Not direct variation because of the plus 1. So not direct variation. And you're right, it's because of the plus 1 at the end. It's not direct variation, it's because of the plus 1. That's one way to do it, but sometimes finding an equation is just downright awful. Agreed? Especially if it's not something linear like this, it's something totally weird. So I'm going to say, let's do one like this. So my letter B, what would be the other way? So check for a constant K. And I'll make my example 3 a little bit smaller data table. So I'll just put in 3 points this time. Actually 2 points this time. So if I have an x being 1 and a y value of 4, so the first point is 1, 4, and the second point would be a 2 and a 7. So x values of 1 and 2, y values of 4 and 7. If it's direct variation, we should have y equals k times x. Well, if we wanted to find k, how do we combine x and y to find k? If I want to get k by itself, yep. So y divided by x. So if I could just cancel those out. So k is going to be y over x. And that k should be the same every time. So what I could do is I could take my first point, my 1, 4, and say, okay, y is 4 when x is 1. Degree k then has to be a 4. So for this first point, my k value is 4. How about my second point? The k value should be the same for this one. So k is going to be y divided by x. 7 divided by 2 is 3.5. So I have k being 4 for my first point, k being 3.5 for my second point. Direct variation? No. So then you could say not direct variation. So not direct.
So does he use like equation work like every time?
Exactly. Yep. Yeah, it'd work every time to check. So I prefer B. I prefer this way here. Just pick a point, pick a second point. Do you want to know a trick that they sometimes give you in the books? If they have multiple data points, often you can get it to work for the first and second point, but it's less likely that it'll work for the ones at the end. So if I had multiple points, I'd pick the first one and the last one to try first. I do that there. But it's up to you. So example 4, you could probably skip it if you wanted to. I just wanted to show you an example of one that works. So if my x values are 1, 2, and 5, my y values are 3, 6, and 15. then if I go through and do y divided by x for all of them, shoot, you could even make it just into a big data table. That if you say this column here is going to be k, which is the same as y over x, here I have 3 over 1, which is just 3, so that's 3 over 1. This one here I'd have 6 divided by 2, which is just 3. And then this one here I'd have 15 divided by 5. I'm just doing y divided by x each time, which is 3. So these here are going to be direct variation. So yes, direct variation, because k equals 3. Like always, they have that same constant value of 3. That should be what it looks like then as you go through and do it. Numeral 4, IV, solving story problems. It's interesting. I taught Algebra 2 for tons of years, and this is the exact same thing that I taught in Chapter 2, I think it was, of Algebra 2. So you're going to see another round of this. It's not going to go away. But this is what they do. They always give you a pair of numbers, like x is this, y is this. And then they go on and say, find y when x is this. And I'm going to teach it a little bit differently than the book does, I think, because in algebra, you're just doing direct variation, at least in this chapter. When you hit Algebra 2, instead of it always being a nice straight line through the origin, sometimes it's going to be a parabola. Sometimes it's going to be a hyperbola. Sometimes it's going to be an inverse square. So this is a way that's going to work no matter what the different equation they give you. But it'll always be, here's a pair of numbers. Here's an x and a y, or a p and a q, or whatever the two variables are. Here's a pair. Then here's one of the ones in the pair. Find the other missing one. So I would encourage you to do this. Say steps. First step, put x and y. So I'm going to put a point xy in y equals kx. It'll always be y equals kx for now. To find k. And my second step then, write y equals kx with a number for k. I'll just squeeze that in there. The number for k. And then 3, find y with the new x. And we will do an example of this really soon, but basically what it's saying is they always give you an x and a y, put them into this equation, and you'll get something like 7 equals k times 4. Do you agree you could find k given that? And I just made up numbers. I wouldn't write this here in green. So once we find now that k is going to be 1.75, step 2 is saying, okay, instead of y equals kx, we're going to write y equals 1.75 times x. We put the number in for k. Good? And now the problem's going to say, find y when x is 14. Then you would just say, all right, 1.75 times the 14. Good? That's kind of where we're going. But let's write out a story problem so we can actually go through and do the steps. So I'll say example 5, I think we're up to. I'm going to say the number of servings. Bad example, just before lunch, I suppose. But the number of servings made. Oh, no, it's not right before lunch, is it? I'm so sorry about that. Directly. I'm so used to you guys being right before lunch. The number of servings made varies directly with the pounds of chicken cooked. With the pounds of chicken cooked. If 4 pounds makes 7.25 servings, so big servings, how many servings will 6 pounds make? Will 6 pounds make? So the number of servings made varies directly with the pounds of chicken cooked. If 4 pounds makes 7.25 servings, how many servings will 6 pounds make? When you get a big story problem like this, what might save you a lot of time and headache is to take and try to change it into a couple of points. And we have a pair of numbers. We have our 4 pounds and our 7.25 servings, yes? Which one of those is the x, the independent, and which one of those is the y, the dependent? So does the 4 pounds depend on the 7.25 servings, or does the 7.25 depend on the 4? Okay, so my 7.25 is going to be my y value, and my 4 is going to be my x value. Agreed? Because I found some people, they get things switched around, and then they put the 6 in the wrong spot. But now the second thing is saying, well, how many servings will 6 pounds make? So it's kind of like the second point is 6 comma something, and we're trying to find the something. All right, so now that we have that, we start out with following those steps. So the first step is take the pair of numbers and put them into y equals kx to find k. So my y is 7.25 equals k times 4. Then I divide both sides by 4, and I get k equals 1.8125. Maybe I'll show my work a second. A lot of people at this point are tempted to say 1.8. But if you just say it's 1.8 and hack off the 125 at the end, we're going to take and multiply that number by 6 really soon. So you just took your rounding and made it 6 times bigger. Here it's maybe not a huge deal, but especially once you start doing like y equals kx squared and you're multiplying it by number squared. So I would just keep this number here. Don't do any rounding in the middle of the problem. It's just going to mess things up. So step 1 was find x, which we did. Step 2 is, okay, now find k, which we did. Step 2 then is take the k and put it in that equation y equals kx. So instead of y equals kx, we have y equals 1.8125 times x. That's kind of what I was looking for step 2. And now step 3 is, well, we're trying to find y when x is 6. So we just take and say 1.8125 times 6. And that'll give me my new y value. So 6 pounds of chicken should make 10.875. And I'm pretty sure you would have gotten 10.725 if you had rounded the 8, so you're off by a decent amount.